starting back up again. All right, so this one is called Basic 2. I didn't go through Basic 2, did I? I think I just went through 1.
Yeah.
Did I make it through Basic 2?
Yeah,
I started it. Well, I'm going to go through a little faster then. I don't think I've done this one, but I'm not sure. Yeah. So we were talking about overloading. I know I covered that part. We were talking about the ships and how we have a ships. Hello! Multiple constructors here. So this is overloading. I'll just kind of refresh, get back in. Okay. Now that we're all listening. I'm sorry? And I should just start this over. Here. Anyway, let me just continue here. If I can just get everybody's attention. I know it's terrible when we come back from lunch. People are still thinking about lunch. But if you guys talk, it's hard for me to talk over you. All right, so I'm reviewing here. We already covered this stuff. Actually, we've already covered it once already. This is the second time through it. We're already covered the second time. This is the third time through this lecture, I believe. What are we looking at here? I'm just going to tell you, just highlight a few things, and then we'll move on to the next one. So we were looking at inheritance. We were looking at overloading, overwriting. And let's see. Overloading, major points, allows you to define more than one function or constructor. So you can overload constructors. You can also overload methods. Can you overload data? Good question. Can you overload data? How do you overload data? You can't overload data. Yeah, data is data, right? So if you redefine data, you've made it again. So here's what people do with inheritance all the time, and it's a mistake. You have a base class person, and person has a first name and has a last name, and then you create an employee, and you put in the employee class first name and last name. You call it the same thing. You just overwrote it. There's no way of overloading it. So you've just basically replaced the first one with the second one, so why have it the second one then? So you want to basically have, if you're going to have a first name and a last name, you have one first name, one last name, and you keep it with one class, hopefully with the person class. And then if you have, let's say for example, a student ID or an employee ID, that would go with the employee class or the student class. It would not go into person because not all people are going to have employee IDs or student IDs. So in concept, you want to divide the data out, put the data in the appropriate classes where it belongs, and don't overwrite it. What you're overriding and overloading are the methods. Constructors and methods, commonly overloaded. So the overload function of constructors must differ in the number and the type of arguments, or both, so that Java can tell which one you mean when you're running it. If it can't tell, then it replaces it, which is how you're going to end up with different data. The funny thing is, though, is you can have multiple first names and last names, which is kind of interesting, but you have to go this in the current object to get the first one, and then if you set the second one to the first one, there's no sense. You've got duplicate data, and it just doesn't make any sense to do it that way. So it's the methods that we're going to replace and overload. They call it hiding, actually. You hide the data when you redefine it because the first meaning of it's hidden. You can Java will allow you to redefine integer I 20 times, and every time you do it, it's brand new, and it replaces, or actually doesn't really replace, it just hides the previous integer I that you created. So it's kind of odd that way. Some simple examples here of overloading is the two squares. One square takes an integer, the other one square takes a string. So that's an overloaded method by example. Let's see, best practices. Well, I've given you that stuff already, so I'm going to kind of go through it here. Skip it. This is the best practices I gave you earlier. Here's an example, if you haven't seen it before, of the Java docs. That's what a Java doc page looks like. You probably have seen it if you've ever Googled anything and looked for a method or for a class online. You see it because the format all looks the same. There's a couple parameters you can change to change the coloring or something, but for the most part it all looks the same. Also covered the concept of encapsulation, and just a few more words on encapsulation. It lets you change the internal representation of the data structure without the users knowing that anything changed. So this happens all the time, believe it or not, with the base classes. Every time you upgrade your Java version, you're getting a different system out implementation, or you may be, who knows. Or you're getting a different math class, or you're getting a different something, because something changed in the language. But you program the same way, and you compile your programs the same way. So that's an example of encapsulation. You can do that with your own source code as well. So as platforms change, internet speeds change, protocols change, your base classes can change as well, and then you just write new classes that right on top of that, and everything looks the same. So you perform arbitrary side effects without the users even knowing anything changed, which is great. So that is also another example of encapsulation in the language. And then a little bit more on the setters and the getters. We know that we have a set something, get something, but it's more than just the name. It's the accessors and the modifiers as a concept. So there need not be both getters and setters. In fact, it's optional, but most people would put it in if you want to retrieve or set the information. It's common to have fields that have to be set and instantiated but never changed again, immutable fields. You can make something immutable, unchangeable, by getting rid of the setter methods, and then you've got data that gets constructed when the object gets constructed and that it stays the same. Why would you want something like that? Well, what if you're setting student IDs or social security numbers? You want two people out there with the same number. Once you set it, it should just stay like that. And you can enforce that in there by just leaving out the getters and the setters, or the setters. The getter you might want, but the setter you don't necessarily need. You can also eliminate the need of that happening by using the keyword final. If you use the keyword final, no set name method is going to work for it because you can't change it. So you can set it in the constructor and then it won't change anywhere else. Let's see, the setters and the getters need not correspond to instance variable names either. You don't have to call them set name, get name. It could be set something, get something, and then it could be working with a name or a telephone number or something. It's common to do so, however, because it's easier to see. Noticing on the previous slide here that we have a ship name, but the method get name and set name, but no ship name in there. So instead of saying get ship name, set ship name, there is absolutely no requirement that they match. Other languages, they do have to match, or they have to have some sort of naming convention to them. In Java, it doesn't really matter. You can name it anything you want. Inheritance, as we've seen before, we extend one class from another class, so the class that inherits characteristics of the class itself is then the inherited class. So the original class is called the parent class, the subclass, or the base class, and the new class is called the child class, subclass, or extended class. I like to use the keyword extended, so I can say it's the extended class. I also call it the base class and the derived class, which is different terminology again, or child class. Child class has access to all of the non-private methods of the parent class. No syntax, no special syntax is needed to call the inherited methods. You just call them as if you were calling the original methods of the class. Here's our example of the person. Just to reiterate the point, employee is going to extend person, and then we're going to have get salary, set salary, stuff like that in there. And then here we have a speedboat that extends ship. And so now our speedboat here is going to be the superclass, and the ship's going to be the opposite way around. Speedboat's the subclass and ship is the superclass. If we follow through that super sub kind of component, then we understand this part here where it says super. So we know this is the current class, and super is the class above us. So it's super good. No, I don't know. It's instead of good, it's just super good. I don't know. It's right above us. So if we say super name, what we're really doing is calling the constructor of the super class, and the constructor that matches the parameter that we're going to send it. So if we have one with name, then we can pass the name to it. And so when we make a new speedboat, we're going to make a new ship and send the name back to the ship. This is what I was mentioning before. You don't want to stick in here, and I've seen this happen before. People put in here, you know, string name, and then have this one set to the name. And then now you haven't done anything, actually. You didn't set the data member for the class. You made a local variable, and you set that one. That doesn't really do anything, actually. In fact, it goes away when the method ends, so it's senseless. So what you want to do here then is reuse the constructor of the previous class, because that data for the name should be private. And it's not in here, or is it in here? I don't think it's in here, but assume we have a constructor called ship, and then it's going to have a string name, and this is what we're calling, and this always is the first line of the constructor, because we want to make the super first and then the sub second. So the first line, if we put this last, we get a compiler error, because it's going to construct the first. If we leave this out, it runs the default constructor if one exists in the base class. If we want to run something that's not the default constructor, we run super. So super is going to explicitly call a constructor for us. We can run super. How many times can you put super in here? Just once. Yeah. If you put 2 lines of super under here, and you put another one, and you go, I want to run this one, and I want to run that one, and that one, and that one, you'll get a compiler, because you can only make one instance at one time of each object. So super is essentially explicitly making the super objects instance for us, running the constructor. So this is how we're sending information back and forth between the different constructor levels. We're passing it. So now we have another constructor over here that's going to run this constructor. This constructor sets x, y, speed, direction, name. It was in the previous example we just looked at. Well, where's the stuff coming in from? Well, it's coming in from here. So once we get it, or from here I should say, once we get this stuff in here, we just send it. We run super and we send it back. And then we can run our own. This one here is going to set the speed to 20, and this one here is going to set the color to 20. What you don't want to do is replace the body of the constructor from the base class and put it into the derived class. That doesn't accomplish anything. So, because you can't normally get at that data anyway. So if you set the name to the name, you'd get an error message, because name's private. It's private inside a speedboat. So it's private inside a ship. It's not accessible to speedboat, which is why we do it this way. Inherited example for testing here. This is just basically going to create 2 speedboats and then create 2 ships at the same time by running the ship's constructors. And what do we got here? Some inheritance points. The format for defining subclasses. Uses the extends, and you use the inherited methods. And then using super for inherited constructors. Only when the 0 argument constructor is not okay. If the 0 argument constructor is okay, we leave super out completely. And remembering super is the first line. So the most common cases is to omit super or use 0 argument constructor of the parent. And then, but super is used moderately often, so yeah. For the most part, you're going to use super. If you don't use super, you're not setting the data members correctly, because your individual class should only be working with its data that belongs to its class, and then whatever comes before it, that should be setting its own. So you can super back all the way through all of the different hierarchical levels. This is just showing you 2 levels. You can make this 100 levels. Every time you go super, it just goes back 1 level. Super, back 1 level. Super, back 1 level. So you pass the data back and you send it super again. So if I had super with 5 items, then I go super with 4 items, super with 3 items, super with 2 items, super with 1 item, and I'm back to nothing. And I have the base constructor maybe on the base class that gets invoked. So just abstractly kind of think of it going backwards, and you're creating the objects. You send the information back, and then you create the objects in the forward direction. First object gets created is the ship, and then the speedboat's the second object. So let's see, only use a super.sum method for inherited methods, which is interesting. Only when there is a name conflict. Rarely used. Why? Because you're going to overload or override. Why put the same method in there? And you can do it with data too, because you're hiding the data, but why do it? Why have a name in the base class and then a name in the derived class that's the same? With the same number of arguments, because you've hit it, right? So if you go super dot something, you're going to run the super. If you go this dot something, you're going to run the current. So this dot name or super dot name is going to give you 2 different versions of the same name. When isn't it just the same name? How many names does a person have? So, but it is common to see super. It is very uncommon to see super dot something, but it's very common to just see this. So super dot is very rare. This dot is not is acceptable. I mean, it's not something that you should not avoid doing. So Syntax for defining some classes. We have the new class extends an old class, and then the old class is called the superclass, the base class, or the parent class. So don't let all of the different scenarios mess you up. It's just different syntaxes for describing the same concept of the hierarchy. So Java does not support multiple inheritance. Does not support multiple inheritance. The class only has one direct parent. It's a single line inheritance, but we have multiple interfaces, which gives us multiple inheritance. But technically, it doesn't support it. But grandparents and great-grandparents are legal in common. So, yeah. Zero-argument constructors of the parent are called automatically if nothing is specified. So when you instantiate a new object, and the system will always call the subclass, superclass's constructor first. So by default, the zero-argument constructor is called. That's why they call it the default constructor. If you want to specify a different one, use the keyword super in there, as we saw before. So constructor lifecycle. Each constructor has 3 phases to it. So you invoke the constructor of the superclass. That happens first. Then the zero-argument constructor is automatically called. So although you're running the second one, the first one still runs. So you get everything set correctly, hopefully. No special syntax is needed unless you want a different parent constructor to run. If you want a different one to run, you call the different one, which is interesting. So initialize the instance variables based upon their initialization statements, and then execute the body of the constructor, which is the third part. So call the parent, initialize, and then call the body of the current constructor. And then so it kind of rolls out and then folds back up in terms of its construction. So overriding the methods with the super.method name. Idea of overriding here: when the class defines a new method using the same name, same return type, and the argument says the method of subclass, then the class overrides the method of the superclass. Only non-static methods can be overridden. Non-static methods. Static methods, you can't override them. Distinguish between local and inherited. Kind of rare, again, by going super dot this dot. So this is where we get the super dot. Super is illegal. You can't go back 3 levels, you can only do it 2 levels. This is always this. But sometimes people want to go super and then they want to go super again. That you can't do. Because there's no super. There's just super. So which is kind of ridiculous. Some languages actually allow you to go back multiple levels. This language, it's the current level and it's 1 past. And then the 1 past goes 1 past. And then the 1 past goes 1 past, if you want it to run that way. And that's how you're stringing the constructors to fire.
So there is no basically direct way of accessing any method of the most parent class.
Correct. Yeah, you can't go super all the way back to the beginning. You can't do it. You can only go 1 level of super. So you go back and forth between 1 level at a time in everything you do, actually, which is how the constructors are working as well. So just to conclude the concept of the person class, and this actually is, now that I'm looking at it, it kind of reminds me of your assignment that we went over as well, the person and the employee. But there's different iterations of it. The first one was with the instance variables, next one was with methods and constructors, and then constructors with this variable. Same thing we did before, so I'm going to sort of skip through it because we've already seen this example. And just see if there's anything else in here that we might want. No. Advanced topics, abstract classes, interfaces. This is the part we covered before, if you remember. So we've already done this stuff here. We've already done the shapes. We got that far. We looked at the shapes in the abstract classes, and I believe we actually finished this lecture at one point. So shape rectangle. Knowing that we can override, remembering the override as well. We can override. And then the package concept. So that part we did. I just wanted to make sure I covered this stuff on the super. And which I don't think I did the first time through. So. Alright, so there's another lecture that I'm going to skip, and the lecture that I'm going to skip is called syntax. And for those people who are still having problems with syntax, you may do this one on your own, but this would be going back to the first weekend. I just went back to the second weekend. I'm not going all the way back to the first weekend in our review. If you're having problems with the basic would be how to make an Eclipse project, which we covered, or, for example, how to execute it, how to compile it. If you are that needing to go back that far, I just wanted to let you know the resource is available, how to create the class. You may also find if you're brand new to programming, this lecture would be good for a review of how to make loops, the for each, the while, the do. And it's basic, you know, how to use arrays, source code structure, yada yada. So that one is called syntax. And for those people, because I still have people asking me questions about, well, where are these things located? For those people who are still looking for the examples, they are in the ones that I've been going over today and will continue to go over today, are in this lecture here, the ones called programming tutorials. The programming tutorials are the ones, and this is the syntax, the first one in the series. And I've covered the basics 1s and 2s. I'm going to start hitting new stuff now because that was the basic review. So, and I figured I killed 2 birds with 1 stone because I haven't seen you in a couple weeks. So I figured, you know, do the basic final exam review first. And then this is the new stuff. I don't believe, and at this point, you know, you can probably guess, there's probably not too many questions on applets. There's probably not going to be many questions on threads or on networking, but those are the topics for this afternoon and for the rest of the weekend. So at this point, I'm pretty much done with my review for the final exam, which means if I haven't talked about it, it's not on the exam. Excuse me? Well, that doesn't mean you should tune me out completely. But the exam is a 25, I believe it's 25, I can't remember, multiple choice questions on basic Java, core Java programming. So just to reiterate the point, because someone did ask and you guys are going to continue to ask me, the exam is on basic Java, object-oriented programming in Java concepts. Nothing on Android, nothing on applets, nothing on networking, nothing on threads. What I did this morning was give you a review of everything we covered in the last 2 weekends. The exam was based upon the last 2 weekends. Not today. Swing. There are questions on swing as well. Yeah. I have some additional stuff for you on swing that I'm going to give you this afternoon that's not on there, but the stuff we covered before on swing, which I haven't covered yet, or haven't reviewed yet with you today, is also on there too. So, what are the topics? Java syntax, extending classes, inheriting classes, abstract classes. Differences between interfaces and abstract classes, object-oriented concepts, API. How to extend and use constructors, overloading and overriding, data members, member functions, identity state behavior. All the stuff I've been talking about this morning, which is that's pretty much all the stuff I've been reviewing. So that's the core 90%, that's 90% of the exam. There's a couple questions, maybe 1 on swing. Very small percentage on swing, nothing on applets, nothing on AWT, outside. No syntax questions, it's all concept-based, theory-based. No syntax like, the correct way to define a class is, no, A, B, or C. No, it's nothing like that. But you want to know the concepts as they apply towards the language? It's not it's an object-oriented programming in Java, not an Android test, not a Java programming test, not a C++ test, not a, you know, it's definitely on object-oriented. It's focused heavy on object orientation. So the object concept, the is a relationship concept, arrays of objects concepts, object, you know, identity state behavior, extending, inheriting, that stuff. If you look at the 2 basic lectures that I just gave you, that's the majority. That's the meat of the exam right there. So, moving right along, let's talk about applets. I don't like to write applets myself. You know why? Because it takes a long time for them to download from the internet. But you know what? Applets are still being used. So I figured it would be an injustice not to mention it. So this is an object-oriented programming in Java class. So I'm going to spend a few minutes, go through a simple little way of looking at it. Applets run from HTML code. We embed a tag in HTML, we run an applet. What's the difference between an applet and a swing program? It's inheritance. That's about it. We're using very similar concepts. I'm going to show you some really cool applets. I'm going to show you how to run them without using the internet, using the Applet Viewer. You might actually find this stuff entertaining. Applets also have a life cycle to them. And we have some basic applet concepts and templates that we'll look at, and customizing applets for use of it. Also looking at the try and the catch and the override. And then controlling the image loading and unloading and all sorts of different things. So basic applet concepts. It runs on the client. So applets follow client-server computing. So that's why I started out saying I don't like applets, because if you make a really big applet, you have to wait for it to download. But it's amazing though, and the other day I went, oh, should I show them applets? And I was thinking about it, and I'm like, and then I went and I said, how many times do I see an applet come up? And I did a test on 10 web pages. 9 out of the 10 actually had an applet component in it. And I went, oh, maybe I should show them applets. It was actually 8.5. It was like a half of an applet piece. I noticed it because, now that applets, they load up and you can see them loading a little Java thing in there. Sometimes it's applet oriented, sometimes it's not. And then you see the little Java thing comes in and you don't see the applet, but there's an applet running. So applets are not 100% just for GUI. They're for program control. Why are applets useful? Because in web programming, JavaScript doesn't do it all. Sometimes you just want to program in Java. And if you want to program in Java and you're going to do it on the internet, you're going to use an applet. Or you're going to use a server technology. So anyway, they do have a place. Applets cannot read arbitrary files. There's a lot of restrictions associated with applets. You can't open and close files on the client side. So Java itself is very protective that way. They can, however, instruct the browser to display pages and generally that are visible on the web as well. And that might include some local files on the computer system. It won't send the information, and it can't write it, but it can read files. So you can also write to the local client disk with an applet. What does that mean? You can save preferences and stuff. So the browser may choose to cache certain files, including some of the loaded applets. In fact, all you have to do is look in the browser cache folder and you can see all the applets, which is actually kind of an interesting test. Go ahead and shop around to 10 different websites. Clean your cache out, go around to a bunch of websites and then look at your cache, and you'd be surprised how many class files are in there. And then well, I guess applets are kind of still being used. I guess this is the conclusion I came to. So you can open network connections other than to the server, from which the applet was loaded as well. And restrictions prevent applets from browsing behind network firewalls. So the link to the client-side code, C code, or call programs installed on the browser machine through an applet. So it's more than just the GUI functionality is what I'm trying to say. So ordinary Java applications can invoke locally installed programs, runtime, exes, process builder, start, all sorts of different things and modules as well, C and C++ modules, native code. Discover private information about the users. The applet should not be able to discover the username of the person running on a specific client or server. There are some restrictions with that as well. So what does an applet look like in code? You can take any program you want. In fact, I had one in the old days and I moved it out and I changed it. But I used to have an assignment that I took a tic-tac-toe game that was a program and turned it into an applet. And then I decided, well, it's too easy. There's like 1 or 2 lines of code that gets changed. What's the main line right here? Extends applet. So the other reason why I'm showing you applets is that it's a built-in inheritance. So instead of extending, we don't have to extend to application, but we're really writing what's called an application. When we write class, we say public class person, we're writing an applet console application. We just put a main in there and we get an application out of it. So we extend applet, so we don't have a main anymore. So then we define variables and we define methods, and the rest of the code looks the same. So we'll explain override later. But here we have the drawing, the paint drawing. So we have this thing called the Applet Viewer, actually, and we also have the ability to, actually, let me see, we'll look quick here. Oh, it is still open. Let's see what's in this example directory, and I'll show you some of these things here. It's this one here. Here we go. So on a Windows system, also on a, I'll just show it to you live so you can kind of see what I'm talking about. On a Windows system, also on a Mac system, as this one is, if you have a HTML file, if you click on it and you open it up with a text editor, I'm going to open it with Text Wrangler here. And let me make the display a little bit bigger for you so you can see what is on the page. Let's just make it a little bit bigger. There, that's pretty big. That's big enough. We see we have a .class file, and the .class file that we're working with. Excuse me. Here we go. This is the HTML viewing the source of an HTML page, and this is how the applet's being loaded. And some of you may have already been doing this, because if you do any web development, this is pretty popular. We have applet. We have a tag for applet. The code is going to be equal to the line of code. This is actually case sensitive and directory sensitive. You have to make sure you get the name in there correctly. But instead of typing in Java space drawLine.class or drawLine, you're going to have the browser load it instead. And this one's going to load it in a window that's 300 by 200. And then if it can't load, it's going to put in here, sorry, this example requires Java. And then underneath it, we have, well, we just have the ending tag. So the tag's in there twice, actually, on here. So if I double click on here, it loads up and it says drawing diagonal lines, but the page is black and I don't really see anything on there. So I have this other thing called the Applet Viewer. And you type in the Applet Viewer, and you type in the name of the HTML file, and it loads the applet up for you. So if you want to run this without a web browser, you just want to see it run, because maybe that web browser doesn't support Java, which is possible, actually. And we just want to see what it looks like from a native perspective. Actually, oops. Oh, wait a minute. You know what? Let me just open up a new shell. And this one's called Applets. I believe I have to be on the desktop. Let me hold on a second. Change directory to the desktop. And then change directory to Applets. And then we have a Applet Viewer. If I type in Applet Viewer, it's going to say, well, what do you want to view? Well, I'm going to type in the Applet Viewer. And then the options are going to be the URL. So I've got one here that's going to be hello www.to HTML. And then lo and behold, I have a little window that comes up. And I see the little window that comes up over here. This is this. And I got 3 little windows that came up, probably because I don't know what this example is doing. It was probably loading it 3 times. So every time that the applet code gets loaded, that tag that says applet, the Applet Viewer parses the HTML file, pulls out the code tags, and loads it up. I have 3 tags into that file, which is how I got 3 little windows coming up. And it's just showing me the applet. And this hello world just gave me, different colors, backgrounds, and stuff. So we don't need a web browser for this. We can actually just run the Applet Viewer. Makes it nice for testing, especially when you don't know, you don't have a browser, let's say, on the test machine that you're writing this on. A lot of people use Linux and Unix for it, but there's browsers that support it. So in any case, some people do prefer the Applet Viewer, but I thought I would show that to you. So browsing caching problems. Here's the other problem. This is why so I don't like applets for a couple reasons personally when I say that, because I don't like the speed it takes, the slowness that occurs in downloading it. I also don't like the fact that the file never gets replaced correctly. So if it's there, it won't get replaced. If I don't clean out my cache, I have old applets that hang around. Not only does it clutter up my computer, it's going to clutter up the cache folder, but it's going to be out of date and not synced correctly with the website that actually ran it. So normally, browsers normally cache the applets. It's like everything. In fact, some browsers don't cache as often, and you can just make the setting change. So when you recompile the applet and reload in the HTML page, you still see the old applet. Very annoying. That's why people like the Applet Viewer. Show me the applet now, the current one. Don't give me some cached web browser problem, or give me this really weird big old page with hello world on the top of it, like I saw before, and it's all black and I can't tell what it does. Just show me what the applet's doing. So that's why the Applet Viewer, again, comes in handy. But if this problem happens in testing, it might lead you to believe, and hopefully you would believe, that it would also happen in production too. So I constantly hear to support people saying, clean out your browser cache, because you're getting the old copy of it, you know, or close your browser window and open your browser window back up. And there's so many problems with applets that way. It's just ridiculous. Because you're running it on the client's computer. As soon as you give it to the client and you let the client run it, then that's where all your problems start. Which is why a lot of the Java on the server side, you're looking at servlets. You're looking at JSP. You're looking at same technologies. Okay, so keep in mind this is all written in Java. Java is Java is Java. Are you going to extend Applet, or are you going to put it on the server, extend, you know, make a servlet out of it, load it up into a server? You know, it depends on how you want to deliver it. So most nowadays, a lot of people have gone to the server route versus the client. In our Explorer Firefox solution here, open the Java console and hit the X to close it. Close Java console, bring Java console back up. Sometimes you see I don't have an Internet Explorer on this computer, and Firefox doesn't show me the Java icon. But sometimes you can hit the icon, close the icon on the bottom of the screen as well. In Eclipse, you can actually run applets in Eclipse by just selecting run as Java applets, instead of using the Applet Viewer, because that's what Eclipse is going to do. Or you can do what I just did a few minutes ago and run the Applet Viewer on it. So the Applet template, I showed you this already, but this is what the tag looks like. You have applet space, and then you have the code, and then you have the height and the width of the applet. And then, you know, if it's not there, some sort of an error message that'll get printed out instead. So the Apple example number 1 is drawing diagonal lines. I have some cool stuff actually. I have an applet that runs like a notepad example. I have an applet that runs, draws some gooey pictures out there and stuff. This one's going to do lines. Let's take a look at the insides, because we already know the Java part of it, but let's take a look at how applets differ. We have this little method called init. Init is like main. It initializes. Well, init. Well, why didn't they just call it main? I'm not quite sure, because then that would have been exactly like a regular old application, I guess. So we have it called init. So it initializes here. What does initialization do? Well, it's going to, this particular case, we're going to set the background color. We got the height. We got the width. We're going to set by getting the height and width. Okay, and then we have this paint. So we're painting. So we're using graphic G. We're using graphic libraries. So I have a mini little lecture on graphics that I'm going to show you as well right after this. But because when you're going to do applets, you're probably going to use some graphic tools. You can draw draw line, draw text, draw screen, which is how we're doing the hello world. So example number 1, the HTML file looks like that. This is the .class file. The imports that we're going to include are applet, and AWT. We're using Abstract Window Toolkit. So it's supported in the Applet environment as well. No difference outside of the init instead of the main, and you're looking at graphics packages, painting to the graphics. So our HTML file, we've actually seen this a few minutes ago with the Hello World one we looked at. This is draw line. Actually, I think I showed you that one. Result looks like that. So if you load up this draw, I believe this one is called draw line, perhaps. If you double click on it, I don't know which one did I call before. That was draw line, I thought. My line didn't show though when I loaded it up. I didn't see the applet in here either, because I don't think my browser is supporting. My browser's not supporting it, which is why the Applet Viewer would be a much better choice for me with that one. So. And now I have an interesting little round symbol going on here, which is going to cause me a problem soon. So we'll just let that go until it times out. I can't, my browser's frozen right now. But if we double clicked on that, we should see 2 little boxes from the 2 little windows that are supposed to open up. It says drawing lines. We see a yellow background with drawing lines. But as you can tell, I have a host browser with a little round thing going around. So that's terrible for testing. It's basically, the window's not going to load for me because this is not supporting Java. it won't let me do it. My security policy won't let me do it. So that's why you want to think about other ways of testing it. But anyway, but if that happens to me, what happens when I go to put it on the website? So in example number 2, what we're looking at is the same kind of code, except for now we're going to put an image out there, a jumping Java image. So I'm going to use the Applet Viewer for that. If we do this, what we see here is inside of here, Java jump. We have the code, and in the code for Java jump, we're loading here from images, jumping Java .gif, and we're putting it inside a little image box. We're going to put on the screen here. We're going to add a label, jumping Java, and then a print line. Well, wow, I'm jiving with Java. Well, where's the print line going to show up? It's going to show up on the console. So, oops, I'm kind of not happy I did that. Let's see. Let's see. Jump in Java. Which one is it? Take a look here. Java jump. I don't know if I even have this one stored there, but is it? Let's take a look. Did you see it? Java jump. Oh, okay, so. Okay, good. So let's see. Is it in here? Yeah, there it is. Java man, it says though. Java. Well, let's just take a look here. Oh, here's Java jump. Okay, so let's just call this one here the Java jump. So you see what happened down here, and this is one of the problems with the applets as well, which is the reason why I wanted to run this. My system output while I'm driving in Java down here on my console window, although my window up here isn't going to show anything. I'm going to see is the great jump in Java. Why do I want to do that? Well, I didn't give the user my image. My image is embedded in here. It may also have some code, but keep in mind that this applet got downloaded to my browser cache directory. So I have the code. All I have to do is decompile it. It's a .class file, but for every compiler there's a decompiler, which means I'm pretty much giving the code away. Long story short, you don't want to write an applet that connects to a server that uploads or looks at or even touches a database that does anything critical. So it kind of limits what you can do with an applet, essentially. I'm going to force quit this. Ah, there we go. Yes, ignore it. All right. So we can see we can write to the console screen, and we can also write to the system out. So standard output down here at the bottom. That's what we saw when I ran it. So we showed up in the terminal window instead of in the applet. So we have the Applet Lifecycle, and then we have the methods that are associated with it. So we saw before the init. The init's the most important one. If we don't have an init, nothing happens. So it's called when the applet is first loaded into the browser. Not called each time the applet is executed. It's only called once when the browser screen opens. So depending upon what's going on, your applet still may be running. It might be active. And your web page has moved on and has done something else, but your applet's still running. Not such a good thing to some people. You can have a start method, and so we can have which is called automatically after the init is initially done. Start method we don't actually have in these examples I've been showing you so far, but it's invoked every time the user turns the page or after having left the page. So it will come back. So you left the page and you came back, and the start method's going to run again for you. Used to start animated threads, because what we need to do is have it restart. Because if we have something that's animated and something that's working, it's going to go away on the init, and it only runs once. And then we have the paint method. The paint's what's going to set the screen for us. So it's called on the browser after the init and the start. The last one we get is the paint method. So there's not that many methods in the lifecycle. Paint's going to draw the GUI for us. Invokes whenever the browser redraws the screen as well. Typically when part of the screen has been obscured or reposted or reset. And the method is where the user level drawing is placed. So then we have the stop method. And if you think about it and start looking at it, and we also have destroy method. This kind of resembles sort of like a Android application at some point. So we have a life cycle that's associated with applets. It's very similar. different. Very similar to an Android, where we have a start, a stop, a destroy. Instead of on a show, we have a init, and then we have a start, and then we have, so the applets have a very similar, so Android is not necessarily a new concept. It's actually sort of running like an encapsulated applet for similarity purposes. It's not, it's a completely different concept. But we can run applets, by the way, on an Android phone with a web view. So it does support, well, it supports Java, so it supports it. So the void start, void stop, void destroy, not standard behavior in Internet Explorer, which is the problem. So you know, every time you start looking at web development, then you start looking at, well, this browser's not compatible with that one, and you get different behavior. So unlike Firefox or Chrome, init is called each time the user returns to the same page with Internet Explorer, and the destroy is called whenever the user leaves the page. So Internet Explorer does a little bit more cleanup for you. Useful applet methods. So we can get a get code base or get document base. So the URL of the document is the applet file, the HTML file. We can get the parameters, retrieving the parameters from the param. Kind of looks like JavaScript. Kind of looks like, you know, maybe a little bit of jQuery stuff in here. Kind of looks like everything with a J next to it. All those other miscellaneous technologies that have a J for Java. You got some compatibility actually between applets. So you can actually have the applet code run other Java code. You can mix and match certain things by picking up certain libraries that will work with it. So it's very functional. And you can actually write real applications in this as well. Useful applet methods: continuing show document, applet context method, and show status, get cursor, set cursor. May not be a bad idea. Set the cursor symbol and stuff like that. Get audio clip, play audio clip. Sometimes easier than relying upon a built-in plugin to the browser. In fact, images, video, audio, sometimes more reliable than Flash, or more reliable than some other, and easier actually than some of the other technologies out there. Get the foreground, get the background, manipulate the HTML page. The HTML applet element. We have some required components. The only thing that's really required is going to be the code, the height, and the width. Everything else, and there's some optional ones you can put in there as well. So the code designates the Java file that's going to run, and then the height and the width. So other attributes might be aligning, naming, archiving, designating jar files. So jar file is a zip file with a jar extension on it. Containing classes and images. But keep in mind, when you jar things up, you're giving the code away. Anything you put in there makes it bigger, has to download before the client will even see it, because it's downloading from a server to the client's computer, usually saved in the cache directory of the browser, and then it's started after it downloads. So it could cause a little bit of delay in the response time and the interactivity. Scripting languages, so it permits JavaScript to control the applets, actually, so it works well with JavaScript. Let's see. So letting the HTML author supply the data, you can move back and forth with applets and the HTML code. So setting applet parameter, in fact, there's lots of ways to do form checking with applets, do order shopping cart information, little Java helpers, I should say. So here's a web page here for setting applet parameters. Little example, and I'm not going to go through all of these, but I showed you the hello www2. It's setting parameters. The parameters were actually set in the tags. Here we have the background. In the background, we had one said hello world. One was black, one was white, one was gray. I think something like that. So we can read applet parameters. This is an interesting one here. We can get the parameter and the parameter name and retrieve the value of the parameter element from the HTML code. So we can communicate back and forth. If no match, it returns a null. So always check the null so you're not setting something or getting something that doesn't make any sense. The name argument is case sensitive as well, so you have to use proper case. And here we have set the background to color gray, dark gray, get the parameter for the background. So we can get and set HTML elements inside of the Applet code, which as a technology gives you some pretty interesting capabilities in terms of working with a native HTML code. Here's the example I showed you actually, but I had the 3 windows that were opened up separately because I ran it through the Applet Viewer. So it was showing me the 3 code sections. If I want to see it all put together, I'm going to have to test it on a browser eventually. But I believe Eclipse will bring it up for me as well. So let's look at the drawing capabilities, because then this leads into the drawing stuff I'm going to give you in a few minutes, which is the same stuff that we did in the Android class actually. Because it gives us a 2D, and then we can use OpenGL for 3G, but this is basic 2D, two-dimensional drawing. Ideas is draw from the paint method, and we can use an event handler for clicks and stuff like that later. Well, we'll see some examples coming up actually. Use the graphics, i.e. a pen object to draw, and the syntax is going to look like this, where we draw a line, draw a circle, or arc. So draw a line from the top corner of the applet diagonally. This is that example that draw the line. Draw a string, so we could put hello world out on the screen. Draws a string. Draw a rectangle, fill the rectangle. So the drawing classes are pretty extensive actually. Do some interesting things with it. Draw oval, fill oval, draw polygon, fill polygon, draw image. I'm going to kind of go through this fast because it's a little bit dry to look at. But knowing that you have those methods available to you gives you a kind of a feeling for how you're going to program the characteristics of the interface. Set color, get color for the background color. You can also set the foreground color of objects the same way. And it uses an RGB scale, so it's the same thing they're familiar with other web programming. You can also set the graphic font, so you can draw hello world in a big font, a little font. Specifying the font to be used essentially, and determining the size of the characters, font metrics that's used for it, set fonts. So let's see, setting the color XOR, so the color for the underlying pixels, and twice in a row will restore the original condition if you want to go back to the original after you've changed something. Just setting the paint mode, so drawing dry. So in this particular case, what I'm going to do now is just show you the examples that are in here, so that if you have an interest, I know, because as soon as I say it's not on the final exam, people lose interest completely. So if you still have an interest in looking at applets as a technology, you might find some of these examples interesting. So what I'm going to do is just take a quick peek and see from here. We have the image box, which I believe is going to show me a downloaded, a JPEG image inside of a box. It's going to be slightly different. Actually, I'll show you the better image box. Here's the better image box, which is, it doesn't resize. So I made the applet bigger, which means if I resize the page, if the components are resizable, what ends up happening is they don't wrap correctly or they don't look in proportion. So that's the image size there. There's one that's called image box. So if I compare that one to this one, I don't believe that image box has a border around it either. It doesn't have a border around it. So the other one had a border. This one actually, no, it doesn't resize either, which is good. So the other one had a border around it, set some different properties for refreshing, stuff like that. Drawing lines, we just saw that. Looking at the Java Man 2, let's just take a look at that one. It's going to put another image out there. Nope, it's going to throw an exception. It's going to be throwing a security exception. So we have this thing called a security policy file, and here it is here, Java policy applet. That changes as being overridden by my other one, which is why it's not working, because I have another one in my class path that's being set. So we have a file we manually set, and if we opened up that file, let me preface this file so I get the right file. We see we have a grant permission security, all permissions. So I shouldn't get any permission errors if this one's actually, but I have another one of these in my class path that's set differently. So on my system, this one isn't going to work. We can grant things to open files, close files, read files. There's an entire set of permissions that can be set. So what you do is you take and you put a permissions file into the project folder or into the area that you're going to need it. And then for all of the applets that you open, in this particular case, I've got a security access control to context check permissions, which means it's not reading that file. It's getting it from another area of my system here. That's going to tell me that I don't have access to this one, which means there's something in there that under my ordinary security policy is being violated. Like it's trying to open up a file, which is what this one's supposed to be doing, I think, actually. Or it's trying to write to a file. Or it's trying to do something for which I haven't given it access. That's the other problem, and I shouldn't really call it a problem. It's more of a configuration thing with applets. So I think the, let's see one thing here. Java Man 1, see one that will probably work. There it is. So this one's going to work. The other one is doing something. In the lecture we'll see in a few minutes. There's a slight change between the two of them. This is just loading up an image, putting it in there. I believe the other one's going to try and write the image, but we'll take a look at that in a few minutes. I'm trying to see if there's anything else in here that is of interest. No, that's about most of the applets here. So let's see. The g.drawImage is what's getting our image in there. We're specifying a file. These examples are pretty primitive. They're just, here's the Java man. It's using a get code base from get image, which basically means go out to the image directory, find something, put it in there. So we're loading up an image. Do you need to do a Java program to load up an image? No. You can just put it in your HTML code, right? But it's just showing you how you can do something. Do you really need an applet for anything? No. Not really either. So just know that you can do it. And rarely you'll end up in a situation where an applet makes sense, actually, to do it. Here we're going to try a URL image, and if we can get it, we're going to catch a malformed URL if the image doesn't exist. So one of them loads it from an internet location, the other one loads it from a local disk, and I believe the other one is trying to write it to the local disk or something. So, and here we have in Java to do error checking, which is based on the exceptions with the try and catch. I believe I gave you some try and catch stuff during weekend number 2. Try and catch, I don't remember if it's actually on the final, actually. I'm pretty sure I have something about exception handling though, but I don't remember exactly what's on there. So here's a couple of examples to refresh your memory. We try something, perform some code that's going to probably throw an exception, and then we catch it, depending upon what we catch. If we're not catching the right thing, the right exception is thrown, we're not going to catch anything. So it's only going to be catch IO exception, catch end of file exception, catch malformed URL exception. But if we put a finally down there, the finally is always executed. So if we catch something, well, if we throw an exception, regardless of whether we've caught something, the finally is going to work. So if we haven't put something in there that we're catching and something else gets thrown, then we can use the finally as a cleanup method. So the at override was kind of an interesting usage in this scenario as well, just to show you that these compiler directives are used for multiple different things. It's used to override or to show that we're trying to override a method. Here's a problem again, and this is the same problem we had. Is it the same problem? No, results no errors, but nothing cool is drawn. Here's our solution with the override that says no errors, but something won't compile since there's no paint method in this particular case. Let's see. What is the difference between these two? No error, but nothing cool is drawn. We put the at override. We didn't include or probably didn't import it. So graphics is not an argument. That's what the problem is. So we're sending the paint method with the wrong argument type. And so what ends up happening in this particular scenario, it reads it, it's overridden it, however, it's not checking the override. So in our regular old examples that we've done in the previous lecture where I used the @ override, it was checking to see that we actually intended to override something. In here it's actually going to check, although we have overridden it, have we overridden it correctly? So it's going to go back, same thing as it did before actually, it's going to go back and check the base method and see what is the parameter for that? And then if paint's not going to run, it's going to let us know. So once you change it to paint, and it's a lowercase paint, then it compiles and runs. So it's very similar to what I showed you earlier. But this is just overriding a built-in method versus one that we defined it ourselves. In terms of controlling the image loading, we have the prepare image, and then we have the load of the image. So we can start. Did you run out of battery? Oh, okay, good. Is that the one for that computer? Oh, good. You remembered to bring it. Remember last time you didn't bring it. Extra credit for bringing your power supply. That's really pushing it. All right. Did you want one too?
Helping too.
Oh, helping. Yeah, that's you can get extra credit for helping. Yeah.
Thanks for keeping my charger, by the way.
For what?
Keeping my charger.
Oh. Oh, that was your charger. Oh, I don't know who that was. You know, last weekend, not to go on too much of a sidetrack, you know how many chargers were left here? This wasn't Monday. This was like last weekend, last Sunday. I had like 4 chargers. Yeah, and people started coming back in for the chargers. Last weekend, everybody left their charger here. Tomorrow, when you leave, make sure you got everything with you. You know, people were like so friendly. They left without chargers. I'm surprised I didn't see computers here too. Huh? After you take an exam, make sure pack up all your stuff first before you take the exam. So when you can leave with everything you came with. I swear there was like 4 different chargers here. So I didn't even know that was one of them was yours. But yeah. Somebody did that?
Yeah.
Oh. Oh, really? I didn't receive it. Or did I receive it? Oh, I may have now on the mailing list. I got yours. But then the TA, yours is the one the TA brought up here, I think. And then there was 2 of them in the back over there. And I don't know. I don't know if those people ever got their chargers either. Should invest in Mac chargers. I can probably sell them here. Let's see, controlling the image loading, in case number 1, no prepare image. The other one does prepare an image. So in terms of preparing an image, the image is not loaded over a network until after the display image is pressed, which is 30.4 seconds in that particular case. It's somebody's license plate that says Java on it. I guess only one guy in Maryland's got this. So I don't know if anyone in California has Java on their license plate. Yeah, it's a real license plate. But this is guy in Maryland from 1997. I don't know. Maybe this isn't real. I don't know. If we compare the 2 methods, what we're supposed to be looking at is preloading an image versus loading an image. One of the things you have with Java, as I was mentioning before, is the time it takes for the applet to load, the images to download, all this stuff. So you can actually make it so it preloads, prepares to load it, so on the server it's already loaded, so it loads up faster. Or you wait. So this one here is with the prepare image that was done ahead of time. We have it down to 0.05 seconds after pressing the button versus no prepare image, which was 30.4 seconds. Okay, it's half a minute, you know. It's not necessarily an extensive amount of time, but it could cause some performance issues. This is just one image as well. If we had a lot of images loaded, that might be a different situation. So. Media tracker. So media tracker is equal to new media tracker this, and then putting the media tracker in to load the image. So using an image object, media tracker to load the image. So controls an image loading. Registers images with media tracker to load the images. So applet thread will block until all of the images are loaded, and then each image is loaded in parallel on a separate thread. We're going to look at threads in a few minutes as well. Probably not till after we take like a 10-minute break, but yeah. Some useful media tracker methods from this object to add an image, check all the images, check for any errors, wait for all of it. So with no media tracker, we're seeing that the image size is wrong. So the differences between the big one and the better one on the image is the media tracker being used versus not being used. So I know you don't have to know what media tracker is or how to load an image into an applet for the final, but here's the examples here of the loading the results. So one of them had a box around it, the other one didn't. One is using media tracker, the other one isn't. Case number 2 is using it, case number 1's not using it. So slightly different effect because of the box, but and that's coming automatically from the code. So. Alright, so applet operations are restricted. So applets cannot read and write to local files, call local programs, or connect to any host other than the one it was loaded from. So it's very restricted in terms of file I/O and network activity. The init method is called only one time when the applet is loaded, unless you're using Internet Explorer, and it's called all the time. So it's not called each time, so you have to use the get parameter to read the parameter data. You can communicate back and forth between applets and the HTML code, and the paint method is used, so it's called each time the applet is displayed. Coordinates in the drawing operation are written top left corner down to the bottom far right hand corner. So it starts upper left 0, 0 coordinates all the way down to the lowest point on the lower right hand corner. Drawing images, you can get the get image for a file image and load it. You can also draw using the draw, so g.draw image to draw the image as well. So I'll leave you with that in terms of your introduction to applets. In fact, that's all I'm going to mention about applets, because applets not so popular, however they are still being used. And then if you're interested, there's probably a couple more in here. You know how to load them now using Applet Viewer. You can go ahead and check them out. They're all going to be putting in lines or putting in images, loading images from one point of view or another. So I think it's probably time to take a break since we just came back from lunch. So I'm going to stop this one and start the new topic on the next.